So as we know, we studied in yesterday's class what is alloys and as well as what are the methods of prevention of rusting. So in this prevention of rusting, we have seen that different methods like oiling, greasing, painting, polishing, galvanization, and as well as tinning, electroplating by alloying. So alloying is one of the best method, like which has almost negligible rate of rusting. So that is why the knives, the scissors, cooking utensils, whatever we are using, everything almost made with alloys only. So even particularly like stainless steel. So even yesterday I told you stainless steel, if you notice it, steel, what is the percentage, everyone? All of you? If you take the steel, steel is actually 99.95% of iron, only about how much percentage, everybody? 0.05% of, yes please, what is that? Carbon. So that is what we used to call as, it's become so hard and strong. So that is only we used to call as what? Steel. So 99.95% of iron with 0.05% of carbon, we used to call as steel. Now, if iron is mixed with nickel and chromium, then we get a stainless steel, which is hard and does not rust at all. Do you understand, everybody? So, if iron is mixed with some other substances, the properties will keep on changes. So, like that, different metals or non-metals, either maybe a metal or non-metal is mixed in a particular proportion. That is what? Who is that? Yes, Suni.
Sir,
Yes. Understand, everybody? So we can mix with any other substance. The substances may be added is maybe like a carbon, non-metal, maybe like a nickel, chromium, metal. We can add it anything. So how to prepare alloys, everybody? The primary metal has to be melted first. Melting the primary metal, and then we have to dissolving the other elements in its definite proportions. So then it is cooled at the room temperature. So that is what alloys we used to prepare. Even the 24 carats gold, the gold which we are using in our India for ornaments and all, is it 24 or 22 carats, everybody? It is 22 carats. Understanding? So means if you purchase the gold, 22 carats of the 22 parts of the pure gold and remaining 2 parts, it will be either copper or silver. So why they will add copper or silver? Everyone, to make it hard enough, because 24 karat pure gold is very, very soft. To make it, it is not suitable for making jewelry. For storage, it is good. Like in the form of biscuits, gold biscuits and all, it is good. But in the form of ornaments, if you want to wear, particularly like our Indian, you can see India, like wearing jewelry is like it's a tradition, it's even compulsory things in certain occasions and all. So the 22 karat gold only we can use it for ornaments, because it is only strong and hard. So that is the reason we always will use 22 karat gold. It is in that 22 parts of the gold is pure and remaining 2 parts is what? Either copper or silver. And yesterday I told you 1 carat is equals to how many grams, guys? Everyone? 0.2. Understanding? So now, if I take the gold, which is the best gold, is 916 gold. So 916 Agmark gold is the best one. So that is the topmost gold, quality one. So in 916 means if you buy 10 grams of gold, 9.16 grams of gold and the remaining percentage is how much? Everybody. Remaining percentage is either copper or it will be silver. Okay, everybody? Understand? So that is what it is. Yesterday I have told you the percentage also. Am I right, everybody? We have done or not? All of you? Yes, please. Harish?
Yes.
So that is what it is. So 916 and remaining 0.84 is either copper or it will be having a silver. So that is what you have to remember it. Now, if you take other metals, for example, if one of the metal is mercury, then that alloy is known as an amalgam. So mainly, many of you people also affected with the teeth decay. Is there anybody who affected with the teeth decay? Please respond. All of you. So if you affected with the teeth decay, if you go to the hospital, for filling the teeth cavity, they will use the amalgam. Do you understand, everyone? So this amalgam is basically the alloys which have mercury as the main metal. Of course, mercury is very poisonous, but if it is made it into alloy, then it does not have anything. So we are having two kinds of amalgams. That is what you see. Mercury is the main metal. Then we will get two alloys. One is zinc amalgam, and the next one is sodium amalgam. So amalgam means itself, you have to remember that. Your mind should say, what is that, guys? It is, what is the main metal? What is the main metal? Amalgam means? Amalgam means mercury is the main metal. So means here what is there? Zinc plus mercury, Hg. And here, what is that? Sodium plus Hg. So if mercury is the main metal in the alloy, then that is what we used to call as amalgam. So this amalgam only we people basically will use for teeth decays. Clear, everyone? So normally for filling the teeth cavities, they will use this one. Next. The electrical conductivity and melting point of an alloy is less than that of pure metals. Already electricity chapter, we got the alloys. Anybody can tell me what is the three alloys we have studied there? All of you? Three alloys which we studied in constanon, manganon, and as well as nichrome. Am I right? So constant made up of two metals, manganon made up of three metals, and nichrome is made up of four metals. All of you open electricity chapter. So their resistivity is more or less than metals, or more or says, please respond. Less or more than that? Anybody? Their resistivity is more or less than metals. Compared to the metals, their resistivity is high or low? Everyone, please respond. Their resistivity is high and the melting point is also high. That is the purpose we will use them in a heating effect of electric current. Is it right, guys? Yes, please. Heating effect of electric current. Understanding? So because of what? Their conductivity is low and their resistivity is high compared to the metals. So there is a tabular called electrical resistivity. Electricity chapter, many days we are practicing from long back. So you can notice it. So the alloys is less than the pure metals. Their resistivity is also high and their corrosion rate is very less and their melting point is also extremely high. Even the best metals we can take alloys, constanon, manganon, and nichrome. So we all knows that. Constanon, if you take it. So constanon is made up of what? Everybody, constanon is made up of copper plus nickel. Constanon is made up of what? Everyone? Copper plus nickel. If I take manganon, manganon is made up of what? Copper, manganese, and nickel. Copper, manganese, and nickel. Next, if you take nichrome, nichrome is made up of four metals. What is that, everybody? Nickel, okay. Nickel, next one is what? Chromium, manganese, and iron. So these are the alloys which we studied in electricity chapter. So what is that metals? I told you, even highlight it and learn it. Sometimes they'll ask you directly the composition of constant, mangan, and nichrome. You understand, everybody? Please respond, guys. So that is what electricity chapter. So this is the objective of alloys making. Sir, why, sir, we should make the alloys? What is the reason? This is one of the reason. We can alter the melting points. We can alter the hardness. We can alter the resistance. We can increase the resistance. We can decrease the resistance. What resistance? Corrosive resistance. Do you understand, everybody? We can increase the corrosive resistance. Understand? It means we can like corrosion is not takes place. That is what? Increasing resistance. So they will never get affected with the corrosion. And increasing hardness compared to the metals by making alloys. See, pure gold is very soft. By mixing with the other metals, it is becoming very hard. Increasing the tensile strength, physical properties. We studied that. Yeah, entirely physical properties will change. So, in decreasing melting point and increasing melting point, alter the chemical reactivities, alter the electrical conductivity. So, these all the things. That is what? This is the objectives of alloys making. Objectives of alloys making. So, these all are the purposes. Clear, everyone? Next, brass. If you take the brass an alloy of copper and zinc. Very important one. So, if you want to get a brass, it has been mixed with what, guys? Alloys of copper. So, alloys of copper, all of you take it. So, if you take the alloys of copper, we are having a brass, we are having a bronze, and we are having a German silver. Silver kadayadu, everybody? German silver. So brass is made up of copper plus zinc. Okay. So copper percentage is 80 and zinc percentage is 20. Okay. Bronze is made up of copper plus tin. Tin symbol, tell me anybody, tin symbol. Tin rock, 90% is copper and 10% is tin. Please note it. And if you take German silver, it is made up of copper 60%, okay, and zinc is 20%, and nickel is 20%. That is the German silver. So these are the three alloys of copper. Three alloys of copper. That is what? Zinc and copper. What is that, guys? Brass will come. Bronze, alloys of copper and tin is actually bronze. So they are not good conductors of electricity, whereas copper is used for making electrical circuit. So if you take the pure copper, is the best electrical conductivity. Am I right or wrong, guys? Everybody? Yes or no? Please respond. Yes, but if it is mixed with the bronze, if it mixed with the zinc, it is mixed with the tin, they are not good conductors. So we are altering the electrical conductivity. That is the one of our objective. Am I right or wrong? Everybody? Well, that is one of our objective, to alter the electrical conductivity, chemical conductivity, decreasing melting point, understanding, increasing the strength, tensile strength, increasing the hardness, increasing the resistance. These all the things are objectives of alloys making. Next, solder. You all people know soldering. How many of you know soldering? Everyone? Yes, please. Soldering time, they will use a one steel-like material. I will remember, everybody? Please respond. Soldering time. How many of you know soldering? There is a soldering time. You can notice it. They will use a wire-like thing. I will show you. All of you know, check it, everybody. So how many of you know that solder? Solder is also a alloy. You all see that the wire which we are using here, he is joining the things. The wire which we are using here, we used to call it as actually solder. What is the name of this one? Everybody? It is actually solder. Understand? So this solder is also a actually alloy. So the solder is actually made up of lead plus tin. So 50-50 percentage. So 50% is lead and 50% is tin. So that is what we used to call it as solder. The wire, guys, the wire what we are using, can you able to see here wire, everybody? So the wire which we are using to join the two surfaces, that is what we used to call as solder. I hope everybody clear. Please respond. I am saying you this is the last thing. If you are not responding, if I call Mr. Johan and Harini and all, don't join in the class. I'm very particular. Because if I am not seeing the progress, I am not going to continue, whomever it is. Okay, so that is what solder. So solder is the alloy of lead and tin. Both is 50-50 percentage. And if you see this one, what is the one of the objective? I told you just now. What is the one of the objective? Everybody can tell me. To decrease the what? Decreasing something. One of the objective is something. What is that? Decreasing melting point, MP. That is what it is. So has a low melting point and it is used for welding electrical wires together. Welding or joining, you can say. So joining electrical wires together. Do you understand, all of you? Yes, please. So this is what it is. Now, if you take, we are having alloys of aluminum also. So if you take alloys of aluminum alloys, we are having dura aluminum. So in this, aluminum 95%, copper 4%, and traces of very less percentage. Traces of magnesium and manganese. So means traces means very less percentage. Next, magnesium. In this 95% aluminum plus 5% magnesium. So these are the alloys of aluminum. So like that, alloys of gold also we can make. What is the alloys of the gold? 22 karat gold. 22 karat gold is a alloy of what? 22 karat gold is alloy of what? Gold. Because it is a 22 karat is what? It is mixed with the two things. What is that, guys?
Copper and silver.
Yes. Either copper or silver. Not copper and silver. Either copper we can mix or silver we can mix. Whatever we want, we can. So that is why pure gold is called, is very, very soft. So the designing jewelry, the gold is alloyed with either copper or silver. So that is what we can say. We all can call it as alloy. So the gold alloy is 22 karat gold is called as alloy of the gold. So this is what all about alloys and the types of alloys and their composition also. So if you are learning composition also, it's more important. So what is the objectives of alloys making? Everybody fastly. First one, increasing resistance. Second one, increasing hardness. Third one, increasing tensile strength. Note it. Tensile strength means holding capacity. Next one, decreasing melting point. To alter the chemical reactivity and to alter the electrical conductivity. So these are the uses of objectives of alloys making. Now, there is an alloy which has been used many years before, understanding in our India. That is what the wonder of ancient Indian metallurgy. So as I told you, metallurgy is the department of engineering department, which will deals about metals and their even as I said, the secretary in Karaikudi is also deals about mainly corrosion prevention methods. So the wonder of ancient Indian metallurgy, you can see here, this iron pillar near the Qutub Minar in Delhi. Those who visited Delhi, you might be noticed it, was built more than 1,600 years ago by the iron workers of India. Imagine just almost it is 6 tons weight, 1,600 years before, from today to almost 1,600 years ago. But till now, it is not corroded, it is not rusting. Understanding? It is perfectly, extremely fine. By the time itself, our ancient people, imagine the iron workers of India, how much they developed, how much they are advanced in technology. Now we are, if we are making anything within 10 days, within 1 month, it is getting corroded and bridge is collapsing. That is collapsing. This is collapsing. Many things we are hearing. But this is almost 1,600 years before they have been constructed, and it is still, the surprise is, it is continuing. So they had developed a process which prevented iron from rusting. So for for its quality of rust resistance, it has been examined by scientists from all the parts of the world. The iron pillar is actually 8 meters high and weights is how much almost, everybody? Yes, please.
6 tons.
6 tons. Sir, what makes this? All of you remember, I will say you the secret. Here it is not there, I will say you. So remember, this is the ancient iron workers develop a best process, this one actually, best process to prevent the rusting of iron, and they made this iron pillar. So what they have done, this iron pillar is basically, the scientists across the world, they have been investigated and they have been done. They have been identified the composition. Actually, the pillar is made up of wrought iron. So there is a types of iron. So please note it. So this is the made up of what? Wrought iron. Actually, what do you mean by wrought iron? WROUGHT. Wrought iron means which is an alloy having iron and low amount of carbon. Iron and low amount of what, guys? Low amount of, yes,
Carbon.
low amount of carbon. So they mixed low amount of carbon. So that is what this alloying process prevented the wrought iron from rusting even after 1,000 years. 1,000 years. And what they have done, you know, guys, our Indian workers, iron workers, above the surface, throughout the surface, understanding completely the surface, they developed a thin coating, thin film of Fe3O4. What is the name of Fe3O4? Anybody can tell?
Fe3O4.
Yes, iron 2,3 oxide. That is only we used to call it as, Hari, magnetic oxide. We used to call it as what? Iron 2,3 oxide, iron 2,3. Iron 2, Roman number 2, Roman number 3 oxide. That is the name of this one, which we used to call it as magnetic oxide. Magnetic oxide on the surface of iron pillar, and they painted it with a mixture of certain salts. They coated the painting which has been used in this is actually painting is with a mixture of salts. Mixture of certain salts. Okay, so because of this one, so if you notice it, first what they have done, they have been actually on the surface, they developed a thin coating Fe3O4 and they painted with a mixture of certain salts, and then what they have done, it was heated and cooled again. So after mixture of painting with a mixture of salts, certain salts, they heated and then they cooled it. So this is actually the ancient metallurgy in India. That is the reason, the exact process they have done. They reacted, they developed a thin film Fe3O4 on the surface and they painted with the salts and then they heated and then they slowly cooled down at the room temperature. So because of that, the inside, the oxygen, prevention of oxygen, everything will never be possible. That is why the iron pillar is still, it is like that. And even the painting, the coating is permanently with it. It is not going like today painted, tomorrow it will be gone like that. It is not. It is heated, painted with a thin film Fe3O4, and then it is painted with a different salts, and then it is heated. So there is a chemical reaction carried out and it has been permanently coated like a paint. So still, even though many years, next 1,600 years also, this pillar will be like this only. But it is slowly damaging because of atmosphere changes. As we are more polluting, more acids are increasing in the percentage of acids are increasing in the atmosphere. So that slowly it is damaging. Damaging means there is a variations from generation to generation, but still it is corrosion free resistance. So that much is it's a very big wonder. Even throughout the world, till people used to surprise about it. Many research is going on to develop such kind of metals, such kind of objects. So imagine that. So this is what about as wonder of Indian metallurgy. So now if you notice it here, uses and properties of alloys. So that is the reason you can see brass. Brass, if you take for example, uses. Brass is alloy of what, guys? Everyone. Brass is alloy of? Yes, please respond. Yes, brass is alloy of copper and zinc. So if you take, it is used for making cooking utensils. Our kitchen, if you go, definitely you can see the stainless steel. You can see the brass. Understand? They uses cooking utensils, scientific instruments, microscopes mainly, telescopes. It is also used for decoration in houses and offices, and it is highly malleable, so has a low melting point, and it is easily casting. What do you mean by cast? Means making into different shapes. Understanding? So casting, Terima, you all people know casting. Melting and pouring into the different shapes, ideals and all they'll make. Yes or no, guys? Please respond. All of you. So that is what? So that is the advantage of only one brass alone. If you take a stainless steel, your kitchen full of stainless steel, many operators we can make, and it is very, very hard. That is why we are constructing the bridges also, steel bridges. You can see that many places we are constructing the steel bridges because it is having high corrosion resistance and extremely hardness. If you take the bronze statues, you might be notice it. Bronze, even Olympics we are having a medal. What is that? Bronze medal. Do you remember, everyone? Bronze is made up of what? Bronze is alloy of copper and, yes, please. Copper and tin. Understand? So we will use coins, bronze coins, mainly the coins which is released by our government, RBI government and all. Bronze coins, cooking utensils, and it is a good conductor of heat. Note it. Bronze is a good conductor of heat and electricity. So it is having high corrosive resistance and also shiny nature. Shiny nature we used to call something. Anybody can tell? Shiny nature also we can call it as? Yes, please. Luster. Okay. So it has a good luster, shiny nature. Which one? Bronze. So like that, solders. What is the use of solders? We used to joining the what? Is to welding the electrical wires together. Understanding? And aluminum, I told you, dura aluminum. Do you all guys know dura aluminum? What is the use? Lightweight, and that is why it is made up of. It is used in manufacturing aeroplanes, spacecrafts, pressure cookers. Understanding? Ship and all, they used to made with this dura aluminum only. It is very hard, highly ductile, very light, and corrosive resistance. Most of the aeroplanes and spacecrafts and all is made up of dura aluminum. Weight is less, but resistance is high. High tensile strength and strong in nature. That is what is the advantages of every kind of alloys. So we are having a different properties and different alloys. So please kindly learn everything and then only you can finish it. Okay. Now let us take metallic oxides of zinc, magnesium, and copper were heated with the following metals. Now zinc oxide. Yes. In which cases will you find displacement reaction takes place? Anybody? Metallic oxides of zinc, magnesium, and copper were heated with the following metals. Yes. Zinc oxide is reacting with the zinc. Is there any possibility? Anybody, please? Yes, please. All of you should respond. So is it possible, all of you? Zinc oxide is reacting with the zinc only. So what will happen? Everybody? No reaction.
No.
Yes or no? Yes, next. Magnesium. Magnesium is more reactive or less reactive? Please. More reactive. So what will happen? Yes, please. Reaction way. So in which case will you find displacement reaction takes place? From zinc oxide, zinc metal can be displaced only by what? Magnesium. Am I right or wrong? Copper cannot be and zinc cannot be. Copper is less reactive than zinc, is more reactive than copper. Here zinc itself is cannot be. Zinc oxide, zinc cannot be. But here magnesium is more reactive than zinc. So what is the reaction will happen? Zinc oxide will react with the magnesium, will gives us products. Tell me, guys. Magnesium oxide plus zinc. Okay, guys? Yes. So that is it. Next, magnesium oxide. Magnesium oxide, what will happen? Nobody can replace because magnesium is more reactive than copper and zinc. Okay, everybody? Yes, please. All of you.
Yes, sir.
Yes. Next, copper oxide. Copper oxide what? Copper oxide can be displaced by zinc because zinc is greater than magnesium, also greater than copper, but copper cannot be. So what will happen? Both can. So copper oxide reacting with the zinc. Tell me, boys, products. Zinc oxide plus copper. Next, copper oxide reacting with the magnesium. So what will happen? We will get magnesium oxide plus copper. So that's all about it. Next, in which metal do not corrode easily? What is the metals? Which metals do not corrode easily? Yes, please. Which metals do not corrode easily? Native metals, or we can say noble metals. So they cannot react with oxygen. They cannot react with moisture easily. For example, gold and platinum. Gold and platinum. They are the least reactive metals. Next, water alloys. Water alloys. Answer you find here itself. Water alloys, guys. Alloys are, where is that? Homogeneous mixtures you can find here. Yes. The substances added may be a metal or non-metal. An alloy is a homogeneous mixture of two or more metals, or a metal and a non-metal is an understanding. That is what we used to call as what is alloy. So it is prepared by first melting the primary metal and then dissolving the other elements in a definite proportion. And then it is cooled to a room temperature. That's all it is. Clear, everybody? All of you?
Yes, sir.
Yeah. So please make. Any doubt? Anybody can ask me. Clear, guys? So this is what about the in-text questions. Now, you have almost half an hour time, so you can finish it. We can of course 3 minutes more. We can finish all the things. So let us answer these questions. So NCERT exercise. First question: which of the following pairs will give the displacement reaction? Make it quick. Seconds people can answer. Seconds. I'm saying you correct. There is a way which you need to study. 100% mind has to be work when you are doing it. Okay. So all of you check it. What is the displacement reaction? Free metal must be always more reactive than the metal which is in combined state. Am I right or wrong? Everyone? Yes. So Na, copper. Free metal is copper. Sodium is highly reactive. So it is not. Magnesium and aluminum. So please never call me A. Call me. Magnesium is only more reactive than aluminum. Not takes place. Iron react with the silver. Is it possible? Iron is more reactive than silver. So it is not possible. So one and only option is what? Everybody, silver nitrate. Understanding? So silver nitrate. Silver is less reactive than copper. So that what will happen? We'll get copper nitrate plus silver. Okay. Equation is very important. Girls, understand, Amma? Everybody. Balancing equation. CnO3 twice. Copper nitrate. What is the state? Aqueous state. Solve it fast. Option D. Next, which of the following method is suitable for preventing an iron frying pan from rusting? What is that? Applying grease, applying paint, applying a coating of zinc, all the above, all the above. You understand, everybody?
Yes, sir.
Yes, but you can notice it. If you choose all the above, you are wrong. Why? Anybody can tell? Yes.
Applying
It
grease.
is actually frying pan. Frying pan means you can apply the grease, you apply the paint, because we are going with the extremely high temperature, increase in temperature. So you apply the grease and you will eat that. Respond, we are going to heat it, correct? So what is the answer? Only.
Options.
Yeah, this is not. These all are preventive methods of corrosion, but not for frying pan. So frying pan is only option is what, guys? Applying coating of zinc. So that is the reason I say you have to be very careful when you are answering. Next, an element react with oxygen to give a compound with a high melting point. This compound is also soluble in water. The element is likely to be anybody? The element is likely to be. An element react with oxygen to give a compound with a high melting point. High melting point. This compound is also soluble in water. That is also don't know. Iron cannot be soluble in water. See that the element is calcium. Why? It will react with oxygen to form calcium oxide. It will react with oxygen, it will form calcium oxide. So calcium oxide, if you notice it, what is happening? All of you.
Dissolve.
Yeah, it will dissolve in water or not? It will dissolve in water and it will form what?